All right, we're going to apply what we learned in the last video to integrals. But before we do that, I want to review something really quickly. If I have the integral of 1 over x minus 3, that's going to be equal to natural log absolute value of x minus 3. And the reason why is we know that if I have the integral of 1 over x, that's also equal to ln x plus c. Right, and you can see that this 1 over x minus 3 is very similar to the 1 over x, okay? So that's why that works. And so here, if I have a 3 out in front, we can see that this would be equal to 3 ln and then x plus 5 plus c. And similarly here on this last one, notice how my variable is changing, but no big deal. I've got that dy. I can go ahead and rewrite this as a 4, the integral of 1 over 8 plus y dy, and that's going to be equal to a 4 ln of 8 plus y plus c. Now there is something that I haven't told you, and it's not going to show up on a test. It might show up on a practice, and only probably once or something, but if you have something like 1 over a negative 2x plus 3 dx, that's actually going to be equal to a number out in front. I'll leave that blank for now. Ln of negative 2x plus 3 plus c. Well, the derivative of a negative 2x plus 3 is a negative 2. We need to cancel that out, so you would do the reciprocal of whatever this number is, be a negative 1/2. Now, like I said, that won't be on a test, it won't be on a final, it won't be on a quiz. You might see it on your practice, so just heads up on that. All right, let's do our first one. And this problem starts out exactly the same way as we did on the other video where we try to put this into partial fractions. So this is going to be equal to a over x plus 5 plus b over x minus 2. We multiply the x plus 5 by an x minus 2, and then don't forget to multiply the numerator as well. Here we multiply by x plus 5, and then again an x plus 5 in the numerator. So multiplying our numerators through, I get an ax minus 2a, and then I get a bx plus 5b. And this is all going to be over, since we have a common denominator, the x plus 5 times the x minus 2. Our next step is to rewrite our x's in front and then our numbers second. So this is going to be an a plus b parentheses x. And then I copy down the minus. That's really important. Okay, and then I would have this and this. So I'm going to have a 2a and then a minus 5b. You're basically doing the opposite, right? Because if I were to do minus times 2a, I get this, and then a minus times a minus, I get the positive 5b. And this is still over my x plus 5 times my x minus 2. So now I'm going to set my a plus b, this right here, equal to 1. And then I'm going to set this 2a minus 5b equal to, well, we already have the minus down, but it's going to be equal to that number right here, which is 9. All right, so now I'm going to multiply the top equation by negative 2, and I get a negative 2a minus 2b equals negative 2. Rewrite this equation right here. That's going to give me that. I'm going to add the equation straight down. That gives me a negative 7b is equal to 7. Divide by minus 7 on both sides. That gives me b equals negative 1. So now I'm going to go ahead and instead of writing a b here, I'm going to write a plus a negative 1 equals 1. Add 1 to both sides. That's going to give me an a equals 2. So what does this mean? Well, this means that I can go ahead and rewrite this entire integral, let me do that here, as the integral of my a, which is 2, over the x plus 5 plus the integral of my b, which is minus 1, all over the x minus 2. And if you forget which one you had a and which one you had b, you can always reference your original setup, which was right here. So here you originally had, let me change color here. You originally had the a over the x plus 5. You originally had the b over the x minus 2. And so you have that same thing down here. All right, and we're almost done here. So if you want, you can pull that 2 out in front. That's going to give you a 1 over x plus 5 dx. Pull that minus 1 out right here. That's going to be a 1 over x minus 2. Okay, and our final answer here is going to be a 2 ln absolute value of x plus 5 minus an ln of x minus 2 plus c. There we go. All right. I think we'll do this one right here together, and if you want to pause the video, try it on your own, you're welcome to as well. All right, so I'm going to rewrite this as a over t plus 4, and if you want, you can keep your integrals or just add them in later. I like to add them in later. Plus b over t minus 1. So now we're going to multiply by that. Okay, when we do that, we're just now going to have a common denominator, and that common denominator is t plus 4 times t minus 1. Now I'm going to do distributive property here, so at minus a. Then this one's going to give me bt plus 4b. Okay, rewriting that now, this is actually kind of interesting. Here you actually have a 0t plus a 1. That's going to help us a little bit. So I'm going to put my t's first. That's going to be an a plus b parentheses t. I'm going to copy this plus, and then I'm going to have a negative a plus a 4b. And that's going to have my same denominator. There we go. So writing this as a system now, I know that my a plus b is going to be equal to 0 because there's no number in front of a t. There's no t at all. So we've got a plus b equals 0. And then we have a negative a plus a 4b equaling this number right here, because remember we have the plus matching the plus, and then we've got that 1. Now this is kind of a nice problem. It just adds perfectly. We don't have to change any equation. So I just cross that out. I'm left with the 5b equal to 1, divide by 5, and I get b equals 1/5. All right, now let's go ahead and go back to this original equation right here. I like to do the easiest one. So this is going to be an a plus 1/5 equals 0 as I'm substituting b into b. I subtract 1/5, and I get a is equal to negative 1/5. So I can go ahead and write this original integral as the integral of 1/5 over t plus 4 plus my, actually that should be a negative 1/5, right? Because that's my a, and the a is right here. And then I'm going to have an integral of positive 1/5 over my t minus 1. And if you want, you can take those fractions and put them out in front, but I think we know that we're just going to have that number out in front anyway. So I'm just going to write it as negative 1/5 ln. This would be absolute value of t plus 4. And then I'm going to have that 1/5 come out in front, ln of t minus 1. Don't forget your plus c, and we are done. So really, folks, this is the same exact thing as partial fractions. It's just at the very end, you integrate, and it's not too hard. Thanks for watching, everyone.